if you, for example, look at different type of applications where SQL injection happens, you have a kind of understanding how this attack really works and in which kind of applications. So you have to predict it, yeah.
Yes, I have a specific question about the data you introduced at the beginning. Because you talked about method,
channel, untrusted data items,
and untrusted data. How do you define them exactly? Are data which are, let me say, input to the application directly by the caller of the application through parameters of a method, or are other kind of data, for example, data contained in a kind of data store, so possibly managed by an external component?
Yeah, so I think it is not that difficult to find the channels and data items, because if your application runs on an application server, and you can see, okay, through which sockets the user's request actually, accessing this application, and in which databases, in which files this application is writing or reading from. And in case of methods, we use this, call graph generators. So because in a very complex application, because I mentioned here only the direct entry and exit points, direct methods. You may also have indirect entry and exit points. So we didn't look at these indirect entry and exit points, but you would extend the call graph generators, to find these things. So the answer is, in particular for the methods, you have a call graph generator showing you, what are the entry points and what other methods these entry points are calling, what are the parameters, and are they writing into a database or calling the public interfaces of other systems, or calling the methods of the Java library, for example, IO library. Yeah. So if you are interested, we can talk about how this call graph generation really works. Yeah, so we have
because my let me say my point and my impression is that what we lack really is a good confinement of the problems. Okay, and so one of the most difficult problems to tackle are, let me say, vulnerabilities or attacks which might arise by, let me say, not directly but indirectly.
Yes.
Some data which was modified by someone else, or some data which was modified by the application under consideration, but through a number of different steps.
I understand.
And this really tends to make the tree of paths that you must follow unmanageable.
I think it depends on the quality of the attack surface measurement method. What we are saying here is, okay, you have excellent code guideline principles. You do everything what you can do in different phases. And measure also attack surface as much as you can, and then reduce it. So you just reduce the risk, but you don't, bring the risk to zero, right? You just reduce the risk. And I agree that in a complex application environment, it might not be enough to just look at the application, right? Because, or service, in this case, we looked at one service, but if you look at this middleware system we have, this is one of many services, right? So you should actually look at the entire environment and try to reduce the attack surfaces, but you may still not find these indirect things, because I can do whatever I can do for a service, but if some other service is writing data or reading data from a file or from a system where the data integrity is actually has been, let's say, modified, the integrity has been broken, let's say, so, and I'm reading the data from this service, but as the service requesting service, I cannot know, whether the data is integrity is okay or not. So, in case of service and applications calling many other applications and services, attack surface measurement might be challenging.
Exactly. So I have some comments. So first of all, you mentioned that in the conclusion, you really want to deal with, really try to reduce this attack surface.
Right.
And that seems to me quite challenging to do, because at the end you needed to shut down some communication channel. But why were they there in the first place? I mean,
yeah, you know,
if they were there, no, probably there were some requirements
exactly.
for them.
This is a very good question. You know, the question is, you know, when I talked to some people about this approach, the response was, you know, we need all of this functionality. So, yes, if you need it, you know, if you need a functionality, there are many different ways how you can implement this functionality.
But
First of all, how you can design this functionality. Yeah. Imagine, for example, you want to provide a help functionality in an application. You know, most applications you have help functionality. So you can implement it in different ways. What you can do, you know what? Okay, I have this help functionality, and can say the users are able to search based on the keywords and find some help information. And if you do input validation, for example, so you probably reduce the risk associated with some vulnerabilities. But if you get rid of the help functionality as a search function and implement the help functionality as a navigation, for example, service, you wouldn't probably have SQL injection problems because the users wouldn't have the possibility to enter code, right? Into the help form, keyword form. So what I'm saying is, I think the ideal thing is when we do design, software design, we should really review the design from the attack surface point of view. Not only, okay, we need to have these 3 tiers, we need to put the server, application server behind the web server, you know, we have more tiers, more boundaries, etc., etc. We should do that. But we should go, you know, we should have a kind of finer design review where we should say, okay, you know what, if you need this functionality, and what are the ways of implementing it, and what is the best way of implementing it from the attack surface point of view. And we should do the second thing at the implementation layer, etc., etc. So, but then you can look at the implementation again and say, okay, we did everything we could do. Now we have a kind of good attack surface, you know, it's acceptable. But now the applications are evolving, right? They are changing. The specifications and assumptions are changing. When you do, for example, you know, patches, or when you do refactorization, you should still get this knowledge. Where should I start? Because it's not 100 lines of code; it is, you know, million lines of code. You should have some kind of you know, intuitive feel. Okay, we will start refactorization here, and probably provide the same functionality in a way that this part of the code has a less attack surface contribution.
That's
so I'm not saying that you should turn off the services and etc. But definitely it's a good idea to know, you know what, if one service was in this top 10, for example, area, and 80% of the customers don't use really this service, let's turn this off. You know, this is how
that's a good point. But in other cases, if you change so that you reduce the number of those channels, you may have an impact on the performance and usability by the user point of view.
You will have always kind of trade-offs. You know, the trade-off will be,
trade-off.
I need this functionality, but it has a, you know, big contribution to the attack surface. So you should try to somehow reduce. You know, if you can redesign or re-implement it, etc. But if you cannot do that, at least you know. Even if you cannot reduce it, at least you know that this part of your code in these million lines of code has the has the highest risk.
So you can.
And the question is now, without measuring it, you don't know it.
That's
because with today's techniques, what you are trying to do is, you are trying to get rid of all existing implementation bugs, security defects. But you don't know, and when you do that, you have some kind of assumptions. But you write an application, this application, you know, lives 30 years, 40 years. You know, if you look at, for example, SAP's applications, you know, we had this R1, R3, R2, R3. So we have still lots of customers using code which have been developed in 80s, right? So we still maintain